of sulfate ion. So this one means that there is sulfate ion in the solution under test. So we confirm sulfate ion. As simple as that. Then we can also use, that is, we can add 4 drops. Instead of using barium nitrate solution, we can also use another soluble salt of barium, that is barium. Add 4 drops of barium chloride solution, followed by 4 drops of dilute hydrochloric acid. You can see barium chloride solution is moving with hydrochloric acid because they have the same anion, that's the chloride ion. Here barium nitrate goes with dilute nitric acid, hand in hand, because they have the same anion, that's the nitrate ion. So we have used barium nitrate solution and dilute hydrochloric acid, barium chloride solution with dilute hydrochloric acid, but the soluble barium salt is coming first. So in another test, we can also try to reverse the order by starting with the by the dilute hydrochloric acid. So we can also say add 4 drops of dilute hydrochloric acid, followed by 4 drops of barium chloride solution. Remember that barium chloride solution is also a soluble barium salt. So the reaction equation remains the same because the barium chloride solution will simply provide the barium ion needed for this reaction here, and then the dilute hydrochloric acid still will serve the same purpose just like dilute nitric acid by destroying any carbonate ion or any sulfite ion that may be present as an impurity. So we here get, in this case, we get a white, we have only changed the acid, otherwise the observation remains the same, a white precipitate insoluble in the acid. We are not saying in excess because the instruction does not talk about adding dropwise until in excess, but adding later on the same number of drops of dilute hydrochloric acid. And in this case, if we have used dilute hydrochloric acid first, followed by the barium salt, then we get just a white precipitate. A white precipitate, and the equation for the reaction in this case remains the same, and the reaction equation is the barium salt containing the barium ion will provide that barium ion in solution that combines with the sulfate ion, and we get barium, we get a precipitate of barium sulfate. So we can see that they are the same just. So the barium chloride and barium nitrate solution plays the same role in the 2 different tests, and then the hydrochloric acid and the nitric acid plays their own separate role of destroying or decomposing any carbonate or any sulfite ion that may be present as an impurity, and which would also form a white precipitate with the barium nitrate or barium chloride solution. So this one here proves that there is sulfate ion, so it is a confirmatory test. Even this test here proves that there is a sulfate ion. So these are the reagents that we can use for detecting sulfate ion in a solution, and these are the different observations which you must be able to record. In fact, you should be able to record correctly, and these are the deductions. All of them are about sulfate ion. These reaction equations can be asked for in your paper too. So you need to be able to write them very easily in that theory paper. That's why I put them here. But in your practicals, there will be no space for you to write these ones here, the reaction equations. These ones are just for your own consumption during your revision. You should be able to write them very easily. I believe you have understood this, and this is how we can test for or detect sulfate ion in solution. So we shall continue with other anions in other different solutions. So Tech Talks Education, thank you for watching.